The two triangle centers that we are going to use the most are the incenter and the circumcenter. Here we'll focus on the incenter. The incenter is created by the three angle bisectors of the triangle. An angle bisector is splitting this angle in half and coming out. It's splitting an angle in half down here and coming out. And then there's another one over here splitting that angle in half and coming out. Where all three of them meet is called the incenter. The incenter has two major properties that are important. One, it is the center of an inscribed circle. An inscribed circle is the largest circle that can be found and fit entirely inside the triangle. The inside circle will touch the triangle right there on all three sides, but it will never cross outside of the triangle. Because it is the center of that circle, then that means that the segment drawn from the incenter to the triangle right there would form a right angle. Going from the incenter, that's not a very straight line. Going from the incenter to the triangle over here would form a right angle, and then from the incenter to the triangle down here would form a right angle. All three of those segments, this terrible one up there and that one right there, are all radiuses of that circle. And since every radius is the same length within a circle, that means all three of them are the same length. That's why we say that this is equidistant, meaning it is the same distance from all three sides. So the key things you need to remember: incenter is created by the angle bisectors. The angle in the incenter is the same distance away from all the sides. This is a drawing in Geometry Sketchpad that's meant to show you this. Here I have all the angle bisectors drawn in, and you can see all of them are meeting at the incenter here. And there is our inscribed circle that I just kind of highlighted all through there. And then these dashed blue lines are the radius of that inscribed circle, and you'll see that from the incenter to K, from the incenter to M, and from the incenter to G, it's always the same length. And you can see those lengths measured over here. Now what I'm going to do is I'm just going to shift this thing around a little bit, and you can see that no matter how I move around the points, the incenter always stays inside the circle, and it always stays with this inscribed circle just touching the sides. And you can notice that our side lengths over here, the lengths of the radius, they'll always stay the same length. Now I can move this around a lot, but that circle is never going to come outside of the circle, so the incenter is always the same distance away from the sides no matter what, and it is always the center of an inscribed circle. I can even spin it so you can see, and you can see that our side lengths are staying the same, and that circle is staying inside the circle the whole entire time. There's the incenter.